Now I want to look at how you would parameterize a line or a portion of a line. And you could write the equation of the line as a Cartesian equation and then convert it the way we talked about before. But it's actually easy to go straight to the parametric without that stop along the way at Cartesian. And that's what I want to talk about. So let's think about how we might do this. Let's think about a line here. If we just draw some arbitrary line. We know that a point, I'll call it x naught, y naught. If you know a point and a slope, some change in y over change in x, right? Rise over run. Those two things define a line. If you know the tilt and where it's located, you have a line. And actually, vertical lines don't even have a slope, right? So let's think about this. What would be true of any other point on that line? So any arbitrary point I can draw, call it xy. To get from the point that I know to any other point, there would be some amount of up and down and some amount of left and right. Right? Now, what's going to be true about these two quantities? Well, their ratio should be delta y over delta x. So what that tells me is that it may not be exactly delta y over delta x. Each of these may not be exactly that delta y or that delta x, but the ratio is always the same, right? That's the point of a line. The slope is constant. So no matter where I'm at, if I go to that point or that point or that point or this point or a point way down here, the ratio of the change in x and change in y will be the same as whatever this fraction is. That's what it means to be a line. So that means that this up and down has to be some multiple of this. I'll say t times delta y. And this left-right has to be some multiple of that delta x. So I'm going to call it t delta x, that quantity and that quantity. So what does that mean? Any other point is to go from any arbitrary point to my known point. I am just adding some multiple of delta x to the x and some multiple of delta y to the y. So that means what's true of every point on the line is it's our initial point, right? I think I just said that backwards, but either way. But from our initial point, from our known point, I would add some multiple of delta x and add some multiple of delta y, right? Because even if these aren't exactly those numbers, the ratio, right, t delta y over t delta x is delta y over delta x. Right? So that's maintaining that slope everywhere. So in order for that to be true, every xy pair that we can generate on that line should be our original point plus some change in x and y that are a multiple of the quantities in this fraction defining our slope. And it's as simple as that. There's our equation of the line. And actually, if you want to go into 3D, which we won't in here, but you would just have a third equation, z equals z naught plus some multiple of the change in z. Now, slope goes out the window in 3D. We're going to use vectors to describe the orientation of a line, but it's still the same concept of you start at some x, y, z, and you move some constant amount along all three directions. Not the same amount, but constant. OK, so let's look at an example. Let's find the line through the points 1, 3, and negative 4, 10. So let's draw a picture. We don't really need to. From the formula, we can just write it, but I just want to think about what we're doing here. So negative 4, 10. Be right there. And 1, 3. About there. We're talking about this line from there to there. And I haven't really mentioned anything about direction of motion. Right now we're just going to be interested in getting the line. Depending on how you set this up, you could easily make this go one way or the other. So what would be our equation? Well, we need the starting point. Well, we have 2 points, so take your pick, whichever one you want to use. So let's say I want to start with the point 1, 3, for example. Now, what is my change in x and change in y as I go from point 1, 3 to point negative 4, 10? Well, to go from 1 to negative 4, you subtract 5. So that's my change in x. And to go from 3 to 10, you add 7. And simple as that, we have the parameterization of our line. Now, there's many ways you could have parameterized it, because remember, this could be any point. And really, all that has to be true is the ratio of delta x and delta y over delta x, should be your slope. So really, any constant multiple of that works as well. That would just speed up or slow down your parameterization. Now, one important thing about the method I just used here is what will always be true is at time 0, when t is 0, you're at the point 1, 3. So you're there at time 0. The point that you pick is actually your location at time 0. And because I make this the change that you need to move to the other point, that's where you are when t is 1, right? 1 minus 5 is negative 4. 3 plus 7 is 10. So you're here at time 1. Direction of motion will be from the point that you used towards the point that you used for the slope. Now, one result of this is if you didn't want the entire line, if you just wanted that line segment, and this is something you'll do in Calc 3, you'll describe a path around a rectangle, for example, as 4 line segment paths hooked up. Well, if I just want the line segment from that point to that point, all I have to do is add something on here, a little domain restriction, right? So if I put this on there, then I don't get the line. I just get the line segment. So it would just be from t equals 0 to t equal 1. So it's simple to turn a line equation into a line segment equation. So simply with that domain restriction. And because of the way that I do it, where I make my delta x and delta y the change from the start point to the end point, this restriction will always be 0 to 1. If you look in the textbook, they do this slightly different. That's why I say the way I do it. The reason I like to do it this way is this jibes a little bit better with the vector approach that you'll use in Calc 3. So just make your change, the change from one point to the other, and 0 to 1 will parameterize it. If you wanted to go from the other point, just use that as your starting point, negative 4, 10, and then these would be the opposite, right? Because as you move there, that increases 5 and decreases 7. So by picking what goes here, you've picked time 0, and your change will take you to time 1, the second.